Team Supertramp has filmed some pretty amazing stunts over the years. But what would have happened if their first stunt at Corona Arch had gone terribly, terribly wrong? Find out in this episode of PS 100. According to Devin's behind-the-scenes video, the cliff his buddies jumped from was roughly 150 feet tall. Team Supertramp's rope swing included a system of ropes with multiple failsafes intended to keep everyone alive. But there were plenty of ways the stunt could have gone very, very wrong. Take this moment, for example. This is Devin's friend, Creighton, in an early take of the video's opening scene. It's a beautiful shot until... If Creighton had fallen over the edge, this is what would have happened. For an extremely brief moment, at the instant he fell over the edge, his acceleration is 9.8 meters per second squared, the full acceleration of gravity. At this moment, he has no vertical speed, he experiences no vertical air friction, and gravity pulls on his body unopposed by any vertical contact forces. That may sound confusing, but remember that acceleration is not the same thing as velocity. Acceleration is the rate of change in velocity per unit of time, and Creighton's velocity is changing awfully fast at this point. As soon as Creighton begins to fall, air friction pushes upward on him, exerting a force against gravity. The faster he goes, the stronger that frictional force gets. If the cliff were high enough, the forces of friction and gravity would balance out and Creighton would stop accelerating. That's what terminal velocity is. But falling from a 150-foot cliff would only give him a 3-second freefall. So friction would slow his acceleration to 7.5 meters per second squared before he hit the earth at 63 miles per hour. When Team Supertramp parties with the force of nature, the danger is real. In fact, the only thing that isn't real on this insane rope swing is the centrifugal force. You heard right. The centrifugal force may feel as real as gravity when that rope gets pulled tight, but this so-called force is nothing but an illusion. There is no force pulling straight outward. The gravitational force pulling down on Creighton makes him accelerate as soon as he jumps off the cliff. Then, the rope adds a centripetal force to the mix once it catches. I know, centripetal sounds a lot like centrifugal. The words are actually exact opposites. Centripetal means center seeking, while centrifugal means center fleeing. Anyway, Newton's second law of motion, the law of inertia, tells us that Creighton's body will naturally follow a straight line unless some force pushes or pulls his body against that straight path. And that's what the centripetal force of the rope is doing. It's taking all the velocity Creighton picked up from gravity and forcing that velocity to accelerate in a curved path. The rope pulls Creighton against his inertia and away from the straight path the law of inertia says he should naturally follow. If you're still scratching your head, imagine what would happen if the rope suddenly snapped when Creighton was closest to the ground. He should fall straight down. Actually, no. Or not yet anyway. If Creighton's rope had broken at that point, he would have kept flying straight forward with all the velocity he gained on the way down until gravity finally put an end to his low-altitude flight. If that had happened, he wouldn't have hit the Earth with the full direct force of a 150-foot freefall. It would have been more like he had jumped out of a bus cruising down the freeway. He would have tumbled and scraped across the sandstone rather than smashing straight into it. That's it for this episode, but you'll find more science and research opportunities for BYU undergrads in the description below.